What's up guys, Mati here. If you have been watching my videos for a long time now, you will notice that in many of them I've used a tool called Docker. And this tool is extremely useful for many things, but I used it because one of the things that it allows you to do is basically have a stack of different tools without having to actually install those tools and configure them, so and so on and so on. You just basically declare the tools that you're going to use, the systems, the different stack that you want to use in a Docker Compose file, and you can run all that stack in your local computer very easily. And you can use different versions of it. So you want to use MySQL, and you can change different versions of MySQL, or you want to use then Postgres instead of MySQL, you can do that very easily. You don't have to actually install it and uninstall it later. So it's really useful, and I've been using it for a lot of things. But I've noticed that many of you have been asking, hey, what is Docker and how do you use it? So I wanted to do this video and show you how Docker works, what are the main concepts that you have when you're using Docker, and how you can run a Spring Boot application in a Docker container. And we're going to do all that, and then we're going to run the same Spring Boot application in a container, but this time in AWS. So this is really exciting. There's a lot of things to learn, so buckle up and welcome to Programming with Mati. Okay, so let's start with the basics. What is Docker? Docker is a platform that was developed for developing, shipping, and running applications in isolated containers, simplifying development and scaling across various environments. What does that mean? Okay, there is one key word that we can focus on, which is the containers. Let's see some of the concepts that we have in Docker. The first concept that I want us to learn is the concept of container. What is a container? A container is a lightweight, isolated environment that packages applications and their dependencies. What does this mean? It's kind of like a virtual machine. It is an isolated environment that packages exactly what you need to run your application. So let's say your application needs Java to run, because we are running a Java application. So we need a JVM to run that application. So in a computer, you would install Java, and then you will be able to run that application. What Docker does is it will create a container which is like a lightweight virtual machine, and it will install Java in that container so that you can run the application in that container. And the good thing is that so these containers are very lightweight, so they're very easy to start and stop, create new containers, and these containers are created from something called an image. Images are the templates that are used to create containers. So if we said that we wanted to create a container for a Java application, what we would need is an image that has Java. So the image explains to Docker what the container should look like. You create an image, and this image is the template that has the code of your application. It has the dependencies, in this case, a JVM, Java, so that you can run the application. And then if you run the image, what you will get is a container. So you can run the image multiple times and in different computers. And this is the power of Docker, that you can run the same image in different computers and it should run the same. It should behave the same way. So how do we create images? Images are created with something called a Dockerfile. A Docker file is basically a script that contains a specific syntax used to create an image. So in the Docker file, you would declare what kind of operating system it will use and what dependencies it will have. So for example, if you want your image to have Java, then you can reuse an existing image that already has Java, and it can inherit that and extend it. And that is a very powerful thing that Docker allows you to do. So if you have an image, you can extend that image, and then you can keep adding new things to that. So usually when we work, we don't really have to create an image from scratch. We start from an existing image and we basically add whatever we want. For example, if I would create a Java application, what I would do is I would start with an image that already has Java, and then I would add the code of my Java application and the entry point, which would be the command to run the application, and that's it. The Dockerfile will be very simple. And finally, Docker is based in a repository logic. So you would have the images stored in repositories that can be accessed by other computers. So for example, Docker Hub is a centralized repository, and you can pull images from there, and you can create your own images with those. Or you could create a new image and then put it in your repository, and then you can push it to the centralized repository so everyone can have access to it. You have private repositories as well. So if you work with a company, they might not publish their images in the public repository for everyone to access. So they would have a private one where only people with access will be able to download that image. And this is what it would look like if we create a Docker file. We would use the specific syntax. We will create a Docker file, and then once we have the Docker file, we can run the command build, docker build, and this will create the image in our local repository. Then with that, we can run the image, and it will create a container. So the container will run in the local machine, and you can have multiple containers in one machine. So that's a very cool feature as well. Another thing we can do with the image, as we said, we can push it to a centralized repository like Docker Hub. And from there, other people can pull that image, and then they can run that image in a different container. They would run the very same image in a different computer, and they would run the same because they are running in the same in a container that looks the same. It's not the same container, it's the same image, but both containers should behave the same because they are using the same base image. There are so many advantages of using Docker. One is the portability. Like, for example, if you create an image for an application, then you can run that image in any machine that has Docker. So you don't really have to worry about installing dependencies and all that. You can download that image and it will basically run it in a container. Another advantage is the isolation. Isn't it awful when you have competing versions of Java in your laptop and you don't know which version you're using for your application, and you have to change the path so that it takes the correct Java version and so on? Well, with Docker, you can isolate your application so that the image already has the proper version of Java required, and you don't have to worry about, oh no, I need to change the Java version so that this application can run, and so on, because everything is isolated and packaged in that image, so you don't have to worry about that kind of things. So if you need to install a different version of an application that uses a different version of Java or a different version of whatever dependency you have, you can do it in an isolated way and it won't hurt your other applications. Then efficiency. It's really efficient because containers are lightweight. They're not like virtual machines. So they're very efficient, and they also reduce a lot of overhead that comes with this. Because of the isolation, you get a lot of reduced overhead as well. Scalability is another factor that plays in here. Thanks to containers, we can scale and descale applications really easily, because all we have to do is we don't have to create a new virtual machine and install everything on it, and we basically create a new container and that's it. So for example, if we have a cluster of machines running in AWS, they all have Docker installed, and we can basically run our containers directly on those machines. And you don't really have to have Docker installed and all that, because AWS can do all of that for you. So AWS has a service called ECS, Elastic Container Service, and that basically creates a cluster with Docker running on it, and it can consume images and run them in containers, and they can be scaled as much as you can. So it really helps with scalability. It's also very useful for tracking versions, because every time you create an image, you create a new version of that. You can create different versions of that image. So if you have a release, you can create a new image with the new version of your application, and that's it. Rapid development. As I said, it's really easy to launch an application because you don't have to download all the dependencies. You basically run the whole all the dependencies with the Dockerfile, and or you have the image, or you can use Docker Compose, which is a more powerful tool to use to combine multiple images and create your own stack. Then collaboration is simplified as well, because we can share images and we can run these isolated containers in different machines. There is a rich ecosystem of Docker images, so there is images for anything that you can imagine. So it's really useful, and it's really useful for continuous integration as well. So Docker is used in CI/CD pipelines for testing, because you can create containers that have a specific set of data and initial conditions and so on, and then you test, and then you delete that container, and that's it. And you can restart you can create a new container from zero that will have no data integrity problems whatsoever. So it's really useful for testing and continuous integration, and it's very useful also for cost savings. You can reduce a lot the infrastructure costs, because basically you can descale and scale whenever you need, instead of scaling and descaling manually. Okay, so this will be our tutorial. We're going to have a very simple Spring Boot application already developed by me, and we're going to create a Dockerfile that will use or will extend the Java 21 image, so that it can run a Spring Boot application. We will build that image, then we'll run that image, and we'll create a container for our Spring Boot application. Then we will push this image into Docker Hub, and we'll pull that image from AWS, so that the same image runs in the cloud. I'm not going to explain a lot how this works and how AWS works in here, because that is a whole series of videos. But for now, what I'm going to do is just show you that this works, and that you can run an image, a Docker image, in so many different places. All right, so here's my Spring Boot application. It's very simple. It just has this main class. If you haven't seen my video on Spring Boot, take a look. It's very good and very useful for this tutorial. So here's the main class, and here we have the books controller, which basically returns a list of books, and we have a record called book with this information. So if we run this application, I'm going to run it very quickly. Okay, the application is running, and now I'm going to basically go here and localhost 8080, and I think I named the endpoint books, and here we have the list of books. So everything is working just fine. So now we want to run this, but instead of running it directly on the computer, we are going to run it in a container that is going to run on the laptop. So how do we do this? First, we need to containerize or Dockerize our application. Yeah, this is a Docker jargon, so you can Dockerize the application by basically creating an image for this application. So first I'm going to create a file, and I'm going to name this file Dockerfile. Okay, and the Dockerfile is going to be located here in the root. So you see here we have the Dockerfile. So far so good. So now the first thing that I'm going to write here is this keyword from. This is going to tell Docker which image I have to use as a base. So there are many images in Docker that I can use as base. I'm going to use one called OpenJDK, and I use colon here to put the version that I'm going to be using, which is 21. So I want an image that is going to run Java, and it has the version 21. So this will allow me to run this application, because this application runs in for Java 21. So now the next thing that I'm going to do is expose 8080. So this will tell the container to expose that port so that it can get TCP calls, HTTP and TCP calls on this port. And now we have to add we can either add the code of the application, or we can run the compiled application. So I'm going to add the compiled application that is already packaged in the jar format. So I'm going to say here, if you don't know how to package your application, this application has already been created in a way that it can be packaged. So I can basically go here and I can run package. So this will run Maven clean package, which is the standard Maven command for packaging an application, and this is going to be packaged into a jar. Because this is packaged into a jar, I can see it here in the target. I'm going to see here there is a jar. This jar I'm going to copy this jar into the image. So I need to tell that to the Dockerfile. I'm going to say add, which is a command. This is a command to add something like a directory or a file from my source system to the file system of the image. So I'm going to say target, and the good thing of doing this with IntelliJ is that it has autocomplete. So I can do this, and you see, and I'm going to copy this into another file. I'm just calling spring app.jar. Okay, so what we are saying now is we're going to create a container, sorry, not a container, an image. From here, we're going to expose the port 8080 for this container, and we are going to be adding this jar into the image so that when a container is created, it will have this jar inside of it, and it will basically be able to run this jar. So now we have the entry point. The entry point is the command that will be run when the container starts. And it can be a list because it's a list of commands. So the command to run this Java application is basically Java, and then we call -jar, and this is because we are running a jar application, a application that has been packaged, and then the name of the jar, so Spring App Jar. Just in case, I'm going to copy this one here. I'm going to put it here so that there's no mistake, and that's it. So now I should be able to run this in Docker. But first, before running it, I'm going to build it. If I run it from here, IntelliJ is going to build it and then it will run it. But I want to do it step by step so that you can see how Docker works. So I'm going to open a terminal. Okay, so now I'm going to build a Docker image. For that, I'm going to execute the command docker build, and I have to send in which folder is the Dockerfile. So I'm going to say it's in this folder, so I'm going to use dot. And then the tag that I'm going to use, which is Spring Boot App 0.0.1. Okay, so now I have built my image, and I can verify that it was built if I run docker image ls. It will list all the images that I have in my laptop. I have a lot of images, but the first one should be here. We have Spring Boot app. So it was created. Excellent, right? Now that I have this image created, I can rebuild it if I want. For example, I can version it. So I'm going to put it version 2 if I want. Okay. Now if I do ls again, I have the version 2 again, right? So I can create as many images as I want in my local repository. So now I want to run this image. So how do I do that? I can do docker run, and the p parameter is going to be the port. So I'm going to use 9090 so that you can see everything is working. And I'm going to use Spring App 0.0.1. Okay, so this is the image that we created. Sorry, it's not Spring App, it's Spring Boot App 0.0.1. Okay, this is the image that we created. Now I'm going to run it. We'll see what happens. Okay, so you see how quickly this container was created, and now the image is running, and we have the Spring Boot logs as always. So if I go to my browser and I do localhost 9090, because I mapped the 8080 of the container to the 9090 in my laptop. So if I do this, I get the same result. You see, it's really, really powerful and really amazing. So now this is a containerized application. It has been Dockerized, and it can be run in any computer. If I share this image with any of you and you have Docker installed, you'll be able to run this application even though you don't have the code or you don't have installed Java in your application, in your laptop, sorry, you would still be able to run this application. That is really awesome. So let's stop this container for now. So far, we have created the Spring Boot application image, and we have run the image in our local computer inside a container. But now we want to push it so that we can run it in a different computer, in this case AWS. And we'll run the same image and see what happens. Okay, so this is my Docker hub. I see here my name, this is my account, and I have these images. So I'm going to push a new image, and for that I'm going to create a new tag for my application, and then I'm going to push it. I'm already logged in, and I'm logged in here as well. You can log in here with Docker login, and this will log you in into your account so that you can push to Docker Hub. I'm already logged in, so I'm not going to do that, but you have to do that if you want to push. So now that I have this, I'm going to first create a tag for my application saying Spring Boot App 001, and I'm going to call this Matthias D. Salerno, which is my account, Spring Boot App 001. Okay, so if I do Docker image ls, I should see this now. Okay, where is it? Not here. Okay, here it is. Here we have this this tag. So now I'm going to push this. To push it, I simply do Docker push and the name of the image, which is this Spring Boot App 001. Brilliant. So it worked. So I should see now here my new image. And here it is. Last pushed a few seconds ago. So this is the image that I use to run the application on my container. Now everyone can use it. So you can download this image and run it in your local host. And it will work if you have Docker, right? So how can I use this to run it in AWS? All right, so I'm logged in into Amazon now, and I have a cluster where I can run containers. This is in Elastic Container Service, and I'm going to do this very quickly because understanding how AWS works and how AWS ECS works, it's a very long topic that requires its own series of videos. This is just to show you that I can use this image and I can run it whenever I want, wherever I want, and even in Amazon or in a different cloud provider, it doesn't matter because I'm using Docker images. So I have a cluster where I can run these containers, and I had to create something called a task definition. I'm going to do this very quickly. It's just for a demonstration purpose. So I'm going to create a task definition. It's going to be called Spring Boot App Task. This is going to go like that. AWS Fargate. This is fine. This is all fine. This is all fine. And here, this is fine. I'm going to put the name of the container here. Docker, no, Spring Boot App container. And then in here, I'm going to put docker.io/Matthias D. Salerno /Spring Boot App 001. Okay. And I'm going to add a port mapping for the port 8080. And I think that's all that I need to add. Let's see, here is fine. This is all fine. I think everything should be all good. Okay, so I create the container, I created the task definition, and now I can create in my cluster one service. So I'm going to create a new service here, and this service is going to be a Fargate service. This is fine. Here is a service, and I'm going to select the task definition, and I'm going to call this service Spring Boot App Service. Okay, this is all fine. Deployment options, this is fine. And networking, this is important because we want, we will create a new security group. So let's just call it Spring Boot App Sec Group. And let's repeat this here. And in here, we're going to say all TCP anywhere and all HTTP anywhere and all HTTPS anywhere here. So this is going to be public. Anyone will be able to access this. And finally, anything here? No, we don't really need anything. So we'll create the service now, and let's wait for a few seconds / minutes until AWS downloads the image and creates the containers and so on. So now AWS is doing exactly the same thing that we did in our local computer. So now they'll get the image, and it will create a container with it. So let's just wait. It will take a few minutes. Okay, so it seems like the application is already running. So if we go to the service here, we can see the deployment was completed. There's one task running. So if I go here to the tasks that are running here, I can go into the task and I can see that the task is running here. Public IP. So here we have the public IP, so I can probably from this IP I can say port 8080/books, and here we are. So this is running in AWS. You see, we have the same application, same Spring Boot application that we had in our local computer, now running in AWS thanks to Docker. So how cool is that? I think this is awesome. So this is one of the cool things that you can do with Docker. It's really powerful, and I encourage you to go and learn even more about it. All right, so what did you think about that? Docker is an amazing tool, right? It has revolutionized the market, and there is almost no one who doesn't use Docker in a way or another. I use it a lot for even my common tests because I like running different databases, and I don't want to install all those databases with all their dependencies and all that. I just want to create a new Docker Compose file and add the different databases and components that I want in my stack, and then I can run all of that locally, and that's it. And it should be as simple as that. So since I've been using Docker, all my testing has become much more easy to do. And you'll see that I've used Docker Compose in my Kafka videos, in some of my Spring Boot videos for MySQL as well, and I will continue to use it. And in the next video, I'm going to also show you how you can use Docker Compose to create your own stack of components without having to have them with all their dependencies installed in your local laptop. So if you like the video, leave a like, subscribe to the channel, share, leave a comment. Everything is extremely helpful for me to keep creating this content. And I'll see you in the next video. Bye.